So today we're going to cover the muscle. This is histology and contraction. This is the hardest portion of muscle. The rest is easy. So what about it? First of all, we're going to talk about what the overview is, right? What are the major things that we're going to find? And one is going to be the function of the skeletal muscle tissue itself, and what will be that function? Guys, function of the muscle tissue is to contract, right? Pretty much to contract, and as it contracts, it moves tendons, and tendons move what? Bones, correct? And we're able to walk, right? Locomotion. So organization of muscle at the tissue level, you're gonna do that. So we're gonna talk about the myosin, the actins, right? The myofibril, right? Muscle fibers and structural components of the sarcomere. We're gonna talk about that as well. This one is a feature that goes into nervous tissue, but you're gonna start learning that one, which is the neuromuscular junction. A neuromuscular junction is no more than a neuron. You guys know what a neuron is? You ever seen a neuron? A neuron is a really simple thing known as a cable. The cable is connected to my head within my brain, and that neuron has an axon, which you can see here, and the axon travels all the way, let's say, to my arm, and at the level of my arm, it fires an electrical impulse that allows my hand to do this, to wave to you guys. So that's the simplest way I can explain a neuron, right? Just a direct connection to a cable. So it says neuron, and neurons look like this. Again, this is my drawing. You know that I can draw a neuron, and this is a myelinated neuron. So a neuron is composed of a soma, which is a body, is composed of a axon, and the last portion is known as axon terminals. Everybody got that? Again, do you need to learn every single detail? No, right now I just want you guys to see it for the first time. Okay? So soma, which is the body, axon and axon terminals. Okay? What are we trying to get through this neuron? An electrical impulse. What is the electrical impulse? Electrical impulse is not more than the change of charges, right? We said that in the cell, what ions went inside the cell? What ions went inside the cell? That was sodium. You got it, sodium. So the overall charge of the cell at the beginning, we said that the inside of the cell charge is what? Negative. That's what we said. And that negative charge, it was created by the proteins, because most overall, your proteins are negative charged. So as sodium comes in here, as sodium goes inside the cell, you start getting more what? Positive charges. And that negative becomes now more positive. What have you done? You just changed the inside of a cell to be negative, and the outside to be, the inside to be more positive, and the outside to be what? Negative. You have created what? Depolarization. This polarization process allows you to send a what? An impulse. What impulse will that be? Well, positive and negative charges, is that electricity? Yes, and the body measures in millivolts, right? Your outlets are 110, 120 oscillating, right? And then 220, right? 240, the ones that have a double 110 or double 120s, right? For the washing machine, like, high consumption or air conditioning. So that is electricity. So that electricity travels all the way from the soma all the way to the axon terminals. Okay? And all it's doing is this, is going from here to here, from here to here. You see, it's kind of like jumping. So that means that sodium goes in at this level, right? The inside becomes now more positive and the outside becomes more negative, correct? Let me make that with a different color. Wait. Second. So now at this level, what happens? Again, sodium comes in, The inside becomes more positive, the outside becomes more negative. And as you progress that impulse all it's doing is, again, it's going into a jumping, right? It just happens here, here, and here, right? So it does kind of like some sort of jumping, right? We call that a saltatory. In Spanish is salta, jumps, right? Conduction, because it's conducing what? Electricity. Does that makes it easier to understand? So all you're doing is sodium going in, right? Making more positive the inside, the outside becomes more negative. That creates depolarization, and that creates that electrical impulse to move forward or towards the what? The axon terminal. Okay? Now, that process, again, we're going to go more in detail there. That process takes place where? At the muscular section. What is muscular? It means that electricity reaches the muscle and tells the muscle to do what? To contract, to move. Does that make sense? So that's the neuromuscular junction. It's a union between a neuron and a muscle. Each one of those muscles. Do you have a way to move your muscles in your body? Yes. Do you move all of your muscles? Hopefully you do. Whether they're consciously or subconsciously, right? So the conscious ones are the ones that you can move, which are your what? Skeletal muscles, right? Your voluntary ones. Your involuntary one is your heart, and your smooth muscle, which is part of your digestive system, respiratory tract, etc. But you have to move your muscles, right? That's the reason why you have them there. So, if you send the impulse, what are you going to get? Most likely, a contraction. If you stop the impulse from descending, what do you get? A relaxation. Okay, so think about moving one finger. Think about it. Think about it. Now move it. Does it make a difference? Yes, that's when you actually decided to send a impulse down. So you can think about moving my hand, I can think about moving my hand, but I don't move my hand until I allow that impulse to do what? To be sent down. And you see, thinking and doing, how long does that take? It's really fast, right? So this works in milliseconds. Milliseconds is 1,000 of a second. So I'm going to count to 1, you're going to count to 1,000. Do it fast. 1. You see how fast that was? So that's how fast that impulse travels. Okay? So, of course, we're going to talk later more about the impulses, but right now we're just going to focus on the muscle. So, muscle tension, right, and type of muscle contraction. What about that muscle tension? What are we going to talk about muscle tension? Well, every time you contract a muscle, please contract a muscle. If you want to do your biceps, your fists, your quads, I don't know, your triceps, your glutes, whatever you want, right? If you contract the muscle, what do you create? Feel it. I want you to feel it. Guys, contract the muscle for me, please. Don't show me if you don't want to, but feel it. Feel it. Do you feel it? That means that muscle is doing what? It's generating a tension. So every time a contraction takes place, a tension occurs within the muscle. Okay? We're also going to talk about the different type of muscle fibers. Okay? So we're going to focus on each one of these things. The next one is distinguish between aerobic and anaerobic endurance. What is endurance? Do you endure yourself often? Do you train yourself often? Do you actually perform aerobic and anaerobic exercise? Yes, I just did. I just ran out, I don't know, 12 flights of stairs to come here to the second floor. I endure myself for today. Right? So, normally, what is the difference between aerobic and anaerobic exercise? The oxygen consumption, right? Which one will have more oxygen consumption? Aerobic. So high amount of oxygen will be. That means that this exercise will be what? A fast and a strong or high output exercise. It will be a slow, continuous, long-term exercise. Slow and continuous exercise. All right? So, anaerobic exercise, that is Low oxygen, high amount of CO2, right? What type of exercise would it be? Short, but really strong bursts of exercises, like when you're lifting weights, right? When you're sprinting, right? When you're running a marathon, that is what? Aerobic or anaerobic? When you're swimming laps, is that aerobic or anaerobic? Swimming, aerobic, right? You're not swimming one lap, you're swimming laps, right? Many. All right. So that's what we're going to focus on, and that way that you endure yourself depends on the type of muscle fibers that you create. You have fast twitch fibers. Which one would you use fast twitch fibers in? Aerobic or anaerobic?
Anaerobic.
Fast twitch. What do we call it? Twitch. What's a twitch? Okay, twitch your eyes. Twitch it. Right? When you have eye twitching, have you ever noticed that when before you get into an exam, your eye starts twitching, and you go like, come on, right? That's because you're nervous and just sending a muscle contraction. So twitch and muscle twitch means what? A single muscle contraction. So fast twitch fibers means muscles that work in a fast-paced, fast environment, and that is doing anaerobic exercise. The other one is a slow twitch fiber. What is a slow twitch fiber? That works in aerobic exercise. Why slow? Well, we said that aerobic exercise most likely what? Is a continuous exercise that you have the longest or the more endurance, correct? Does that make sense? So it does depend what type of endurance or what type of exercise you perform in your life, then your body could shift to either slow, fast, or intermediate twitch fibers. So you have three. So you have fast, slow, or intermediate twitch fibers. Now, what do you usually do? Anybody? Do you guys do any exercise? You walk to school, right?
Yeah.
What do you do?
Aerobic.
Do you run? Are you almost all the time late? Then you're definitely going into anaerobic exercise because you're running. If you're on time for most of the time,
Aerobic.
there you go. So if you're in time most of the time and you take your time to go up the flights of stairs, you do a slow movement, just continuous movement, you continue to move the whole day, most likely you're doing what? Aerobic. So you are incentivizing, right? Or increasing the chances of creating more slow twitch fibers. Does that make sense? If you do a mix, which all humans do you do a mix of exercises? Sometimes I'm late, I'm gonna run. Sometimes I'm okay, I'm just walking. So if you do a mix of exercise, right, evenly, then your fibers should be intermediate. Means a little bit slow, a little bit fast. The next question is, can you change them? He says, I think so, yes. And the answer is, yes, you're right. Now, you can switch them, right? You can create new slow, new fast, or more intermediate ones. It just depends how you train yourself. Can you train yourself to run a 100-meter dash or just 50 meters?
Yeah.
You can run every day and become faster and faster and faster, right? You can train yourself then to run a full marathon, right? A big difference. So marathon is definitely an aerobic exercise. So it takes what? It doesn't take a week to run a marathon, right? It takes at least
Hours.
hours?
No.
Oh no, to prepare. Yeah, no. Yeah, to run it, yes. But to prepare to run it, it takes months, right? I'll say at least 1 month, which I got it. But month, right? 3 months up. Because it takes time for your body to get from the fast or intermediate fibers to make more slow twitch fibers. I'm going to talk about what the difference is later on. So I just want to spend time in there. So difference between a skeletal muscle fibers, cardiac, and smooth muscle. All it is just structure. The only thing that I'm really looking for is on skeletal muscle, what you really need to know is that skeletal muscles have striations, right? The cardiac muscles are striated as well, but they have something known as, you got it, intercalated discs, okay? And you also have your smooth muscle cells, which of course, cardiac and smooth, you have no control over it. Smooth muscles are not what? Striated. So let's look at it, right? They're a spindle-like shape. So that is the summary of what you're going to see now in the chapter, okay? Let's move into the game. First of all, let's talk about the main three types of muscle tissue. As mentioned before, you have skeletal muscles. Let me make this a little bigger, better. So the first one is a skeletal muscle. You can see that you have full control of the skeletal muscles, right? It is a voluntary, correct? So that skeletal muscle, you can see you have a bunch of striations. You see the striations there, right? So it moves your skeleton. It guards the entrance and exits of the digestive, respiratory, and urinary tracts. And of course, it generates something that you really know here in Florida, which is what? Generate heat. Also protect the internal organs. Do you want me to give you an example, or you're good with what I just said? Samples? We're good. Samples? All right. Abdomen. Does it protect my internal organs? Yes. The rectus abdominis protects my internal organs. Right? I'm not going to go into other ones. That's the most obvious one because you have no bones there, right? Now, the other one is going to be guards the entrance and exits of my body. Okay, do me a favor. Go like this. Just while you're going to give a kiss. That is guarding the entrance. What type of muscle is that? Orbicularis oris, right? Orbicularis oris. What about the one around the eye? Orbicularis oculi. And then that is guarding the entrance. Well, wait. I have an entrance on my pee-pee and I have an entrance in my anus. What is that? Well, that is known as skeletal muscles. Do you have control over those? Yes, you do. Really?
Yeah.
Yeah, you do. So on the urinary tract, you have both internal and external sphincters for the urinary and anal or rectal, right? Let's call it rectal. It's actually the anus. But urinary, you have internal and external sphincters. For the anus, you have internals and external sphincters. You guys know what a sphincter is, right? So the external sphincters, all of them are made out of what? Are made out of skeletal muscles. Do me a favor. Imagine that you have the urge to go to a bathroom to do number one. I want you to elevate your pelvic floor. Okay, go. Elevate, squeeze them on the front. Squeeze in the front and push up. Everybody can do it, both males and females. Can you do it? Come on, guys, do it. I'm not going to look at you. I can't do that. So if you do it, do you feel that you're squeezing the front part of your body? All right? Well, they call that something known as, ladies, you know the exercise? Kegels. The guys know it. Shame. Kegels exercise, all right? And then on number two, let's say you want to have the urge to do number two, to go to the bathroom, you can elevate your rectum, or in this case, you can elevate your anus. So do it, pelvic floor on the back, push it in. Do you feel that? That means that that is the external sphincter that is working, and that is made out of what? Skeletal muscles. So, do you have control when do you pee and when do you poop?
Yes,
yes you do. And that is provided by skeletal muscles. Okay? Which are the type of individuals that tend to suffer from this? Elderly individuals.
Babies.
Babies. Why newborns? Why toddlers? Because they are in the age that their nervous system is still developing. They still have to learn how to control these muscles. So that's why they poop and pee on themselves. Okay? Now, in accidents, if you have a traumatic accident, a car accident, right, a motor vehicle accident, and you have damage of one of your spinal cords, right, that on the pelvis, most likely that is going to dictate or is going to prevent you from having control of your front or maybe your back. That means you will pee and poop on yourself for the rest of your life. You have to wear a pamper. Okay? So that's the application from there. Now, smooth muscle, the next one is smooth muscle are spindle-like shape. Okay? The main thing about this one is that it moves the food, urine, and reproductive tract secretions. So anything that is a hollow organ. You guys know what a hollow organ is, right? So hollow organ, let's say like the inside of the blood vessels, that has smooth muscles. The inside of your stomach or digestive system, that has smooth muscles. Can you control your digestive system when to put food down into your stomach or into your intestines? No, right? So that is smooth muscle that is doing the work. Again, smooth muscle, spindle shape. Okay? Now, the main thing that I want you guys to see here is that, you see, it's there in orange. It says calcium binds to calmodulin. Okay? What is calcium binds to calmodulin? That is on the smooth muscle. Calcium will bind to calmodulin. That is something specific that takes place in the smooth muscle. Also, in the smooth muscles, you have intermediate filaments, and these are known as desmins. And the contraction of the muscle, instead of taking place within the muscle, that's what we're going to spend most of our time, it takes place the opposite way, which is what? From the outside. So, from a smooth muscle, what do you need to learn? Come on, guys. Nobody's going to say anything? You have a spindle shape. What else? Central nucleus. What else? The calcium binding to calmodulin. And that the contraction takes place from. And if you see the word desmin, you know where that is from, right? That's all I want you guys to remember. These are key words to select what choice. Smooth muscle. Oh, I forgot to put. If it says lining the hollow organs, well, that's another key feature, right? Lining hollow organs. So the lining of hollow organs. So those are the key features for the smooth muscle. Again, are we going to spend a lot of time on smooth muscles? No, this is the whole time that we're going to give to it. Where are we spending most of our time? Skeletal muscles. So cardiac and skeletal, both of them have striations. You can see that the striations are here. Right? You can see striations on the top. You can see the striations here. But if you look at them, the skeletal muscles have like some sort of like a Y shape, and they interconnect within each other. I'm going to zoom in, and I want you to take your attention to this structure. And that is known as an intercalated discs. That means what? And that structure is only found in cardiac muscles. What is the function of that intercalated disc and why it's so important? This intercalated disc allows for ions to pass freely through it. Means what? Sodium, potassium, chloride. If sodium and potassium chloride pass freely from here to here, back and forth, what are you actually sending? She said it. When you shift sodium or charges around, what are you shifting with it? Electricity, right? So that's why the heart is able to contract so fast, okay? So much that does your heart ever stops? Does the cardiac muscle stops? If your heart stops, would you be alive? No. No? Technically, yes. It stops for how long? 3 seconds?
2 minutes, right?
Huh? $250 milliseconds. That means you have to count 250,000 within a second. Go for it. 1. So that means, right? That means that it's what? 1, 2, right? It's like 1, 2, 3 is like 0.20 or 0.250 within a second. Can you imagine how fast that is? But this features allows your heart to never get what? Okay, what? When you contract and relax your muscles all the time, what do you get? Okay, 2 push-ups. Give me 1,000 push-ups. After you finish the push-ups or squats or whatever, how do you feel? Tired. So it never gets what? Tired. That means what? That it can beat for the rest of your, hopefully. That's what we want, right? Does that make sense? So that small amount of gap of contraction allows your heart to never become tired. Okay? So it can beat all the time. So your heart is controlled by its own pacemaker. And you guys know this. What is the pace of your heart? Okay? I'm going to do it in a different way. What is your heart rate? What is your normal heart rate? 60 to 100. Anything below 60 is called what? Pretty. Anything above 100 is called what? Tachycardia. Right? Does that make sense? So that is your heart rate, also known as the pace of your heart. Within what? Because we did numbers, but we didn't do time. So 60 to 100 what? Beats per minute. Okay? If you don't believe me, grab your radial pulse. Okay? You can look for your watch. You can do it in 15 seconds and multiply by 4. Or you can just do it in 30 seconds and multiply by 2. And it gives you your heart rate. Okay? In this case, it will be pulse rate. Maybe a slight difference. Okay? So, straightforward. Let's put together all these muscles and let's contrast here. So what is the main difference between a skeletal, cardiac, and smooth? As you can see here, skeletal are what? Striated. Cardiac is what? Striated. Which one is not striated? Smooth. Okay? Cardiac, what does it have that nothing else has it? Intercalated discs. Right? That's what it has that nothing else has it. Smooth muscle. What is only found on smooth muscle? First of all is the calmodulin, right? The calcium calmodulin. And we have the spindle shape. Any other cell here of muscle cell, would it have a spindle shape? No. Everything else is striated. This one is non-striated. What of these three, which one is multinucleated? As you can see, the only one that has multiple nucleus within one cell is your skeletal. So we have contrast, skeletal, cardiac, and smooth muscle. Okay? So what is the main function? 6 main functions of skeletal muscles. As we mentioned before, as the skeletal muscle contracts, it creates tension, and that creates what? Movement. What allows your skeletal muscles to move your body? The connection between the bone and the muscle, or the muscle and the bone, right? Who makes that connection? A tendon. So if I lacerate my tendon, if I cut the tendon of a human being, would that person be able to move? No. Right? I mean, the muscle will contract, but it will not move any bone. Okay? Now, maintain posture and body position. If you relax your whole body, I want you to please relax your whole body, you're not being relaxed. If you relax your whole body, just, right, it will be deplanated all the way through. Right? So, maintaining body posture is also something important, which is, again, is made by muscle contraction. The muscles that allow you to maintain body posture are those fast or slow twitch fibers. So posture. Fast, do you maintain your body postures only once and the rest of the time you're lying down in bed? How do you maintain your body posture? For how long? No, not whenever you want. You maintain it all the time, because if you would not have that body posture right now that you have, Relax your arm. If you were to relax everything. It would just go boom like that, right?
No.
No? All right, do me a favor, just relax and see how your body's gonna start to give up. I mean, yeah, because you're not in the chair, but your body would just give up, right? Your head would just be the plummet all the way like this, right? So your body posture takes place throughout the whole day. That's not what? Slow or fast? That's a slow twitch fiber. Support soft tissues. What do you mean support? Well, it prevents soft tissue from being damaged, right? We said the example of protection of the rectus abdominis that protects the actual internal digestive systems, right? Internal organs. We also have guarding the entrance, as we mentioned before, right? Maintaining body temperature. If you get too cold, what you should do? Well, you shouldn't do anything. Your body does it for you. So if you're naked, wet, and inside a minus 30-degree room, what do? You shake, shake, shake. That's what you do. You shiver, right? And by shivering is an automatic reaction that your body is taking place, so you can actually do what? Warm up your body, but mainly it's not your body that you want to warm up, is that you want to warm up what? Your blood. Because if the blood gets really cold, what happens? Slows down. Have you ever put a little bit of blood or meat on the freezer and you see the blood? What happens to that blood?
Coagulates.
It coagulates, but it also gets what? It freezes. So a frozen blood, does it move?
No.
No. Do you need blood to be moving all in and out all the way through your blood? I mean, through your circulatory system to deliver oxygen and pick up CO2 and nutrients and all that? You do. So if your body cannot maintain a temperature, your blood will freeze, you will become ischemic, and then you may end up, as you've probably seen in the movies, with what? Hopefully you only end up with this. On the tip of the fingers, we call what? Frost bites. That means people start putting, getting a back coloration, right? A black, not black, it's actually maroon-like, bluish, and then black. That becomes necrosis because there's no blood to that area. So we call that frostbite. Okay, store nutrients and reserve. What nutrients are going to be stored here? So what are we storing on the actual muscle? We're storing mainly glycogen. Yeah, you're right. That was the next one. But mainly what? Glycogen. Where do you store most of your glycogen? Is it in your muscles? No. Glycogen is mainly stored in your liver. Glycogen is sugar, guys. Glycogen is a big molecule of sugar. It's a polysaccharide. So, liver is the main place, the first place where you store the glycogen. Glycogen then it can be stored in your muscles. Okay? Why do you want to store glycogen in your muscles? Do you need your muscles to work all the time?
Yes.
You do. Can your muscles wait for you to eat something that can go into your bloodstream and then go into your muscles? So you can move? Wait, hold on, don't breathe. What? I need to breathe, right? So those muscles will have a storage of glycogen so they can break the glycogen and create what? In the mitochondria, ATP. So again, glycogen is a sugar, right? It's broken down, then is used by the mitochondria to create ATP, the energy that moves the muscle, right? Protein, well, you guys know, right? How many of you are a muscle eater? Oh, sorry, meat eater. Yeah, you're eating proteins, okay? And then, of course, you also have some electrolytes which are always stored in there, right? But not a biggie, right? There's not a lot of electrolytes that you can barely use, but there are electrolytes as well. And that leads to the next thing. We're looking now about we're looking at the anatomy of the muscle. So let's look at the anatomy of the muscle. From the outermost to the innermost, right? The main thing that you see in a human individual underneath the skin is going to be your skeletal muscle. Now, a skeletal muscle is not one, is that hundreds and thousands of them inside, right? The way I like to teach this is imagine this as a Russian doll, okay? So, have you seen the Russian dolls? Like the little doll inside the other doll, inside the other doll, inside the other doll? Right?
And then,
Muñeca rusa. Right. So, on the outside of a skeletal muscle, you have a layer that protects it, and that is known as the epimysium. Epi, outside. Then, inside that epimysium, you have the next segment. So, one inside the other, right? So, first of all, skeletal muscles, then you have what? Muscle fascicles. They don't put the word muscle because everything is muscle, right? You have a fascicle. So that means you have fascicle inside a big muscle. Okay? If you think about this, have you ever seen the sausages? So imagine putting a bunch of sausages inside a big bag and seeing all the way from the top. That's what you're looking at here. Each individual one is like a little sausage. I don't know if you can see that. I'm hungry right now, so
yeah, me too.
that's what I thought of. So, but that is each one of those inside that big structure, that epimysium, which is the skeletal muscle, is your fascicle. Then inside the fascicle, you have either smaller ones, and those are known as fibers or cell. Why the word muscle? Because all of them are muscles. So you have skeletal muscle, muscle fascicle, muscle fibers. Everybody got that? So let's do it with me. From the smallest to the biggest, what are they? Fiber, fascicle, and just the muscle, right? The skeletal muscle. Now, what is covering the skeletal muscle? Epimysium. What is covering the fascicle? Perimysium. What is covering the fiber? Endomysium. And this is cut by some recent put. So that is the covering. That's the outer covering. That means that the epi, well, let me go from inside to outside. So the endo, the peri, and the epimysium, they all connect at the end here. What is at the end here, guys? A tendon. So at the end, those three layers of covering create something known as a tendon. And that tendon is what connects to the, well, you guys know that here is a bone, right? So that's my bone. Oh no, it's just a weird bone. I'm not even gonna draw it. All right, so that is the anatomy of it, right? So what is the other word for a muscle cell? A muscle fiber. Awesome. So inside that muscle fiber, do you know the stuff already? Well, some of them you do, because you do already the nucleus. You already know the mitochondria, right? What else do you know? I guess that's it. Endomysium, well, that is because you have something different or similar to what the cell is. I'm going to go in detail now. So inside each one of those muscle fibers, you have structures even smaller. We said skeletal muscle, fascicle, fiber. What is the last one now? Oh my God. Yes, I'm sorry. You're right. Give me images. There you go. Come on. So you go from skeletal muscles to fascicles to fiber, and the small one is myofibrils. That is the smallest structure. That is inside the cell, the muscle cell. So you have a question about fiber or just they say muscle cell. So please know what that is. What is a myofibril? These are tiny filaments. Every time I touch it. So these are tiny filaments, and these filaments can be either thick or thin, as you can see there, right? Thin or thick. If the filaments are thin, then we call them actin. If the filaments are thick, we call them what? Myosin. So you learn three things now. inside the muscle fiber cell, you have the myofibrils, and they are either inside their structure, they're either thin or thick, and they're either actin or myosin. The way I remember this one is, if you're thin, you can act. You're an actor. It's easier for you. If you're thick, well, you're the other one, myosin. If you like it, use it. If you don't like it, toss it away. It's just a way of remembering the words. Okay? Now, yeah, I'm gonna do this one on this one. It's a lot better. So, muscle cell. This is another view of the same structure. There's nothing new here. You already know most of these things. Did we already talked about calcium? We did. Did we already talk about thin and thick fibers or filaments? Sorry, we did. So look, what are you looking at? The same muscle, cell, and or fiber. We said that inside of that we had what? Myofibrils, that they were either thin or thick. Remember that? Right here, we just did that. Inside the myofibrils, they're either thick or thin, right? So that's what we're seeing here. So, what does that mean? That surrounding these myofibrils, they require what? For contraction. Every single muscle requires calcium, right? And requires energy. So, requirements for muscle contraction are what? What is needed for muscle contraction? First of all, we need to have what? The stimuli, right? If you think about it. I have calcium, right? I have all I need. Am I moving? No. I need to be able to send the stimuli, right? So first of all is you need the electrical impulse. And we said that electrical impulse is going to be provided by whom? I'm going to do it here in the back. You can do it anywhere you want to. Neuromuscular junction. Remember neuromuscular junction? It's a weird word of saying neuro to muscle connection, right? That's the electrical impulse. Now, after we got the electrical impulse, what do we need? The impulse is already at the muscle. What do we need now? We need the calcium that we talked about. We also need, she said, energy. Energy is a broad word. What do we need? That gives me energy. ATP. How do I get ATP? Bluetooth, Wi-Fi? Link connections? How do we get ATP? So from where, right? ATP, it'll be, where do we get ATP, right? ATP what? And that is from what? Mitochondria. And then the question is, how? What do you need for that mitochondria to make ATP?
Cellular respiration.
Okay, we need cellular respiration. You keep giving me stuff, I'm going to give you more questions. So cellular respiration.
Glycolysis.
Okay, glycolysis, Krebs cycle. Glycolysis, Krebs cycle. Electron transport chain. All right. The only thing I wanted you guys to say?
Glycogen.
Where do we got the energy from? Yes. Glycogen. The whole purpose of making ATP is using what? What is already stored in the muscle. The glycogen, the sugar component. And that glycogen is going to be converted by the mitochondria through, yes, thank you guys very much, by a process known as cellular respiration, which includes glycolysis, right? The Krebs cycle and the electron transport chain, which is going to generate what? ATP, and that is that we known as what? energy. How many of you are confused? I'm going to say only two words. Mitochondria, glycogen. More confusion, less confusion? Hopefully less, right? You need glycogen and you need the mitochondria. Any questions? So if I need a muscle that is going to perform from the whole day, do I need to have more mitochondria or less mitochondria? More. Do I need more glycogen or less glycogen? More glycogen, right? That's the fuel. Do you need more gas for, I don't know, 1,000-mile trip versus 100-mile trip? Definitely, right? The gas of the muscle is the glycogen, right? Or the glucose. If you have glucose, even better. I don't have to convert anything. Okay? Okay. So, what structure, let's put here structure, is related to the electrical impulse? Neuron, right? What structure is related to the calcium? Right here. Sarcoplasmic reticulum, SR. Do you remember that we talked about rough endoplasmic reticulum and smooth endoplasmic reticulum? Well, this is a derivative of what the reticulum that one was, right? Either rough or smooth, but this one is known as sarcoplasmic reticulum. Why do we call it sarcoplasmic? Do you remember that inside of a cell we call it what? What is the inside of a cell? That whole fluid compartment, what do we call it? Cytoplasm. Look, plasm. Do you see the word? Plasm? Now in the muscle, everything is going to be what? Sarco. So sarcoplasm, and that's where this thing comes into play. Sarco is on the sarcoplasm, right? And it's a what? A reticulum, which is what we saw already. Rough or smooth endoplasmic reticulum. And look, it says, is the smooth endoplasmic reticulum of the skeletal muscles. Correct? So, sarcoplasm, the reticulum. What is the main function of that? It says right here, store calcium. So that's the structure. The next one is energy. Well, you guys know the answer, energy. What's the answer? No, structure. We're doing structures. Neuron for electrical impulse, sarcoplasmic reticulum for calcium, for energy. What structure? Mitochondria, guys. I'm not trying to be tricky. Just the structures that do these things, right? So that means you need to know the function. Again, that's the structure, and the other side is the what? The function. The function that allows you to do what? Contract your muscles. So let's go into a little more detail. So we went over the sarcoplasmic reticulum, we went over the sarcoplasm, right? We're now going to talk about a little more into that sarcoplasmic reticulum. So what are the different parts of the sarcoplasmic reticulum? Towards the end of the sarcoplasmic reticulum, we have something known as what? Terminal cisterna. Like terminal cisterna is the end. Right? I'm going to color code it for you. The yellow is your sarcoplasmic reticulum. I don't know, can you see the difference between yellow and green here? So the yellow, the middle part is your actual sarcoplasmic reticulum. The end of the sarcoplasmic reticulum is known as what? Terminal cisterna. Okay? What happens at that terminal cisterna? Calcium is released. So, which one stores the calcium? The SR, sarcoplasmic reticulum. At what level of the sarcoplasmic reticulum that calcium is released? At the terminal cisterna. Okay? And then this calcium would then diffuse all the way in the surface. You see it's mounted on top of the myofibril. Do you see that? So calcium will be diffused in the actual myofibril. Okay? As it's being released. The other structure of or to the sarcoplasmic reticulum is going to be the triad. The triad is just 3. Triad means you have 2 terminal cisterna and 1 new one, which is your T-tubule. Why do we even care about the triad? We don't care that much about the triad. We care about the T-tubule and the terminal cisternas. So the T-tubule is the one that conducts the impulse, okay, to the interior of the cell. What is the muscle cell called? Thank you. You can read. So, when we talked about here, and we said a structure, impulse, electrical impulse, we said neuron. What else should we put there that is related to the impulse? When we talked about the structure and we said sarcoplasmic reticulum, calcium, what else should we put there? Terminal cisternas. Do you get it? All we're doing is pairing up with what you already know. Okay? If you pair things up, your brain will pick it up faster, simpler. Less stress means more knowledge. And then, of course, you already know what the mitochondria is, right? Which is the ATP part. I don't have to go over that one. So, just a little review. What is the anatomical composition of your muscle? Is from outer to innermost, or from biggest to smallest? Is going to be your what? Skeletal muscle first, followed by your fascicle. Everything is muscle if you look at it. Followed by your what? Fiber, which is known as the cell. That's what we were talking about now. And then inside the cell you have the tiny what? Fibrils. And in those myofibrils you said you had either thick or thin. So those are known as myofilaments, which are thick or thin. Okay? Actin or myosin. So look what it says there on the orange section box. It says skeletal muscle cells are known as what? Myocytes. Look, what are you doing? You're confusing me. Yes, I just told you that you have a muscle fiber, which is the same thing as a what? Muscle cell, which is the same thing as a what? A skeletal muscle cell, which is the same thing as a myocyte. How many of you are confused? You're not confused? It makes sense? Awesome. I was confused. There are different ways of asking you the same muscle cell. So if you want to write it down, you can just do this. Right? You can say muscle cell, right? And then you can just write down all the names. And you put their synonyms, or you just put whatever, same thing, right? Whatever you want. And then you write down what? Fiber. What else are you going to write? Skeletal muscle. Has to say cell, please. What else can you write there? All right? Everybody got that? So that means the same thing. So if you see any of these questions or these names in the stem of a question, you guys already know what to look for, right? Or what the structures they're looking for inside. Okay. Now, where does all these muscle cells derive from? Something that has the word what? Blast. Right? Myo, muscle, blast. So those are the papa and mama cells, right? Now, these muscle cells, they are very long and they increase in size. I don't know what you're talking about. Okay. When you work out, when you develop in life, as you train your cells, right? As you strain your muscles, some muscles of your body will be bigger than others. Why do you have more muscles in your legs than in your arms?
You use them back more.
Because your legs, you use them all the time, and they need to support a heavier weight. Hence, the muscles on your legs are going to be more hypertrophy than the ones in your arms. Does that make sense? And that means that these muscles, you don't have more muscle cells. You have the same amount. It's just that become longer as you get bigger, right? Or increase in height, and they become wider in size. But you don't have more of them. Does that make sense? So they're longer and bigger, but not more. No more numbers. Okay, numbers are pretty much the same. So when you go to the gym, or when you strain yourself, or when you work out, or when your daily life takes place, that means that you're increasing or hypertrophying that muscle cell, okay, in size. If that is the case, then you have within that muscle fiber more what? Okay, let me go back. When we talked about, we said that inside the muscle cell, you had a structure known as a myofibrils, right? So those myofibrils that you have in there, they are cut or are segmented. The segmentation is here. From Z line to Z line, you're going to see that here. So these myofibrils have a Z line to Z line structure. If they become longer, that means they have more Z to Z line. Does that make sense? So the purpose is not the Z line, the purpose is this word, sarcomere. If that little sausage becomes longer, that means you have more sarcomeres along the way, right? As you grow up, you have more and more sarcomeres. I'm not going to go smaller than this. Trust me, I'm not. Now, what is the whole purpose of a sarcomere? This. Smallest functional unit of that muscle fiber. In other words, that is what actually truly contracts. When you have all these sarcomeres contracting inside that muscle cell, inside that, what is on top of the muscle cell? Fascicle, which are inside the skeletal muscle. That's what makes your whole muscle contract. Okay? Yeah. I'm not there yet, but yeah, sure. When you consume all the oxygen, the aerobic, and you become an aerobic exercise, and you consume all that glycogen, your muscles, as a way of getting rid of that CO2, right, they produce lactic acid. And that's what actually makes the burning sensation in your muscles, the lactic acidosis. And it should go away as long as you keep training, because you increase the blood flow to that area of the tissue. That's why for competitive athletes or people that like to take supplements, you can take a vasodilator, which allows you to flow more blood to the tissues, so you have less effect of that burning sensation and accumulation of lactic acid. You can take one out of the counter, over the counter, that is L-arginine. If you really want to work out, you don't want to feel no pain, take L-arginine. Side effect of L-arginine: it decreases so much your blood flow that you may pass out. Because if you dilate your blood flow, your blood vessels, more blood flow is going to take place, but your blood pressure is going to decrease. So you have to be constantly drinking water as you work out, because you may faint and pass out. That's one of the side effects. Sure. If you take the electrolytes, right, the Gatorade and all that works, because you're supplementing with the electrolytes. But the whole purpose of this is if your body is not efficient because you haven't trained it enough to increase blood flow to get rid of the lactic acid, you have the burning sensation faster or sooner than anybody else, because all this takes training. We're going to talk more in detail. Okay? So again, what is actually contracting within that muscle? Sarcomere, as all the sarcomeres in the whole muscle, in the whole myofibril contracts, that means that you're contracting not the sarcomere nor the myofibril, but as well as the muscle fiber, then the muscle fascicle, then the skeletal muscle. That is the hardest thing to get out of this thing, is the actual what? Order of things happening. Okay? Now, everything is going to move towards the M line. And M line is easy because that is known as the middle line. When you move things, you're going to move things. Imagine that my hands are C line to Z line, right? As I contract my muscles, each one of my sarcomeres are going to get what? Shorter. Contract your muscles and you feel that you're going to see that your muscles get shorter. Get your biceps, and if you do this, you feel it. If I grab a point, one end here on my biceps where the tendon is, you can feel the tendon. And you grab the other one, right, where the tendon is, right there, and you contract the muscle. For me, there's a little gap there that I have the muscle. For you, it should be the same thing. There's a little gap that is created because the muscle is contracted, it gets shorter, and it creates more tension. So, as the sarcomere contracts, all of them, you are creating what? Tension in that muscle. The muscle is getting shorter. That means that from Z line and Z lines are getting what? Closer together. Okay? Anything that you see there that is thick, which color you see that is thick? The purple. They're really thick, right? That is your thick filaments, which you already know. Those are myosin. The red ones are known as what? Thin. Those are actin. And the green ones are known as titin. Titin is a beautiful thing. It is a filament that has an elastic protein. That means that your muscles, once they contract the sarcomere, it recoils back. That's what titin does. Right? It's like a rubber band. And we're done with this part. Oh, one more thing. Can you please say hi? Hi? Hi. When you say hi, what are you using? So when you contract your muscles, what things move closer or tends to disappear? The H-band. As the myosin and actin overlaps, the H-band disappears. Like all you're doing is moving this actin all the way through here. So that band that is created here is no longer available. Okay? The I-band, as you get these things closer, right? This space right here is no longer available. So H and I is every time the muscle contracts. Means they get shorter and disappear. You get that part? So when you say hi, the H and I is shorter or disappears. Okay? Shorter or disappears. Because they come together as the whole thing squeezes in. Right? Now, this is the sarcomere on a relaxed muscle. You can see that it is relaxed, right? You have your C lines and your C lines all the way through, right? Now we're going to go into the sliding filament theory, which is, what is the sliding filament theory? And that is, here is a sarcomere, the same thing that we see, or that we saw, sorry, and you see your Z lines should be here, right? They're not, because now they've been what? Moved farther together. Your H-band is going to be closer or disappears or shorter. And that means that every time your actin slides over your myosin, what am I doing? I'm sliding one on top of the other, correct? And we call that muscle contraction, sliding filament theory. That's all it is. because actin slides on top of the myosin.
Yes, it's
A contraction of a muscle, it includes the sliding filament theory. It's a theory that they say that the actin goes on top of the myosin and one slides on top of each other.
When a nerve impulse arrives at the muscle, it causes a release of a chemical called acetylcholine. The presence of acetylcholine causes depolarization, enabling calcium to be released from the sarcoplasmic reticulum. The calcium binds to troponin, changing its shape and so moving tropomyosin from the active site of the actin. The myosin filaments can now attach to the actin, forming a cross bridge. The breakdown of ATP releases energy, which enables the myosin to pull the actin filaments inwards, contracting the muscle. This occurs along the entire length of every myofibril in the muscle cell. When an ATP molecule binds to the myosin head, the myosin detaches from the actin and the cross bridge is broken. When the ATP is then broken down, the myosin head can again attach to an actin binding site further along the actin filament and repeat the process. This repeated pulling of the actin over the myosin is often known as the ratchet mechanism. This process of muscular contraction can last for as long as there are adequate ATP and Ca+ stores. Once the nerve impulse stops, the Ca+ is pumped back to the sarcoplasmic reticulum and the actin returns to its resting position, causing the muscle to lengthen and relax.
So that's the sliding filament theory. Now, for that sliding filament theory to take place, what needs to happen? Words. What do we need it for muscle to contract? Calcium. Calcium that was released from the sarcoplasmic reticulum, remember that? And it diffuses all the way into your what? Terminal cisterna into what? What was underneath? Not the sarcomere. The myofibril. Look at it. You have your sarcoplasmic reticulum here, right? That is on top of this structure that is underneath. That is the same thing as your. So that's another myofibril. Does that make sense? So as the calcium goes from the sarcoplasmic reticulum in or out of it, that calcium goes on the surrounding hopefully you get it, of the myofibril, right? So that calcium is actually binding to something there. And that something is known as what? One is bind to troponin, and troponin, right, moves tropomyosin. Okay? That is moved on tropomyosin. So calcium binds to troponin, tropomyosin is moved, and now what is inside or in between this troponin and tropomyosin? Actin. And actin gets exposed, and then that way actin can bind to these myosin heads.
A contraction is triggered by a series of molecular events known as the cross-bridge cycle. In a skeletal muscle fiber, the functional unit of contraction is called the sarcomere. A sarcomere shortens when myosin heads in thick myofilaments form cross bridges with actin molecules in thin myofilaments. The formation of a cross bridge is initiated when calcium ions, released from the sarcoplasmic reticulum, bind to troponin. This binding causes troponin to change shape. Tropomyosin moves away from the myosin-binding sites on actin, allowing the myosin head to bind actin and form a cross bridge. Also note that the myosin head must be activated before a cross-bridge cycle can begin. This occurs when ATP binds to the myosin head and is hydrolyzed to ADP and inorganic phosphate. The energy liberated from the hydrolysis of ATP activates the myosin head, forcing it into the cocked position.
That is the sliding filament theory, right? That's the whole purpose of it. Cross bridge. So you have a myosin head moving and binding to actin. We call that a cross bridge. So we needed to first create what? A cross bridge. If not, the sliding filament theory of contracting my muscle would never happen.